box. Anything in the whole world could have been outside the physical existence. So if we look, we get our first look outside the physical existence, and we find what is there are the four primary attributes of God. We have to say, this is really, really strong scientific evidence that God exists. I would say that would be conclusive evidence that God exists. So, what do we find out from Einstein's special theory of relativity? I just might mention for those here who are Muslim, on the Isha prayer, usually it is okay to just continue on. Isha is acceptable to pray late. I generally pray just before I go to bed, as a matter of fact. But if anyone needs to leave, that is okay. But if you feel okay, we will, for most of us, we'll just continue through until we're done, and you can pray. It is up to you, of course. I'm not trying to make anybody pray. So, what does Einstein's special theory of relativity say about light? And one of the things that Einstein's special theory of relativity says about light is that the faster you go, the slower time goes. Probably a lot of you have heard this, right? That the faster you go, the slower time goes. Now, this has actually been proven now. See, for a long time, people thought Einstein's theories were just too, I guess I'd have to use the word bizarre. You know? I mean, why should time change when you go faster? Why should time go slower? Matter of fact, how can time go slower? It doesn't seem possible. We used to think time was just time. Well, time isn't just time. Time is bound in how fast you are going. It's also bound in the gravitational effect. But the faster you go, the slower time goes. And so they said, well, yeah, he could say that in his theory, but it sure be a hard thing to prove. You know, because if I had one watch going 40 kilometers an hour and another watch going 140 kilometers an hour, I'm not going to be able to tell any difference. They'll both look like they're going the same speed to me. But later on, they developed atomic clocks accurate down to trillions of a second, and they also developed space travel around the planet, in orbits around the planet. So what they did is they took two synchronized atomic clocks, accurate down to 1 billionth or 1 trillionth of a second, and they left one on Earth, and they sent one up in a satellite. Now the one on Earth is going to be traveling, I don't know this in kilometers, I have to say it in miles. It's going about 1,000 miles an hour. And the one that is up in space is going about 90,000 miles an hour. Now the difference between 1,000 and 90,000 is not huge, but because these clocks are accurate down to billionths or a trillionth of a second, they left one of these atomic clocks on Earth, one of them in a satellite going around, brought the one in the satellite down, and noticed there was a difference in the time in the two. And the difference in the time was accurate to what Einstein's special theory of relativity said that it would be, down to about 6 or 8 decimal points. I mean, it was only, a few billions, or how many billions of a second difference, because, like I said, the difference between 1,000 miles an hour and 90,000 miles an hour is nothing compared to the speed of light, which is 186,000 miles per second. But still, it did prove that time does slow down as you go faster. Now, there is a limit to how fast matter can go through space. There's no limit, actually, to how fast space can expand. There have been times when space has expanded much faster than the speed of light. As a matter of fact, that's why we have a light horizon, because if you get out 15 or so billion light years from where we are right now, space is expanding fast enough and it is moving away from us faster than the speed of light. So that the light that leaves the stars that are outside the light horizon, it's traveling toward us at the speed of light, but space is expanding faster than the speed of light, so that light never gets to us, and that's why we can never see outside that bubble that we are allowed to see, and that's where the 10,000 billion stars are. So, the limit of speed of something traveling through space, then, is the speed of light, or 300,000 kilometers per second. Excuse me. So what would happen if something were to be traveling at the fastest speed possible, at the speed of light, 300,000 kilometers per second. Well, as time slows down, as it gets closer to the speed of light, at the speed of light, time stops. Time does not pass. So if we measure how long it takes a photon to get from the surface of the sun to the Earth, which in miles is about 93 million miles, we say it takes 8 1/4 seconds for light to travel from the sun to the Earth. But light travels at the speed of light. So from our point of view, this is where Einstein's, why it's called the theory of relativity. It's not that everything is relative. Perception is relative. Perceived from our point of view, light takes 8 1/4 minutes to get from the surface of the sun to the surface of the Earth. How long does it take from the point of view of the photon? What if the photon, if I look at my watch, it takes 8 1/4 minutes. What if the photon had a little tiny photon watch and it's looking at its watch? It looks at its watch when it leaves the sun, and it looks at its watch when it arrives at the Earth. How much time has taken place? 0. No time at all has passed. And when this photon ends up at the other end of the universe, still no time at all has passed. So for a photon, no time passes. A photon is outside the flow of time. That's the nature of light. That's one of the special characteristics of light, to be outside the flow of time. By the way, I forgot to mention that there are 3 characteristics that are required for something to be in the physical world. It has to have mass, in flow of time, and it has to have dimension. It has to have volume. Everything we know of in the physical existence has mass, is involved in the flow of time, and has volume. So, first of all, I want to, before I talk about the 4 primary attributes, so I've already talked about the eternal nature, but I really want to show how light does not exist in the physical world, because light does not have any of these 3 characteristics. So I just showed how, according to Einstein's special theory of relativity, light is not in a flow of time. How about mass? Say, for instance, this marker probably weighs, a fraction of a gram. Not only does time slow down as speed increases, mass increases as speed increases. As you reach the speed of light, mass becomes infinite. Now, what do you think if a photon because photons travel at the speed of light. So if a photon had some mass to start with, traveling at the speed of light, its mass would be infinite. What do you think would happen to us if we were being hit every moment by billions of photons with infinite mass? We would be smashed bad. Right? We wouldn't exist. So therefore, the only way a photon can travel at the speed of light and still have 0 mass is to start with 0 mass. The only thing that cannot increase, the tiny, if it had 1/millionth of a gram mass, at the speed of light, 1/millionth of a gram resting mass will be infinite mass in motion. So therefore, a photon must have had no mass to start with, because when it's going the speed of light, it still has no mass. So therefore, the photon has no mass. How about dimensionality? This marker has 3 dimensions. It has its width, and its height, and its length. Another one of the remarkable things about Einstein's special theory of relativity is that any object going, as its speed increases, the dimension of that object, which is in line with the flight, in other words, in this case,